All right, guys, sorry again for having you watch the video for Tuesday's lecture. I really had to go. It's a legal obligation for me to go there. But good news, it's done, right? So I'm back to normal, okay? So I think you're really supposed to study the lecture from section B. That's kind of the assumption for today, just in case you haven't. So please catch up as soon as you can. And today, I'll just pick up from basically where we left off. But I'm going to give you some very quick recap about what we covered from Monday's lecture. And then today, we're going to continue with it. And we'll continue with the OOP review lecture as well for another 2 or 3 lectures. And then you have your programming test 0 coming as well. Okay, we'll review. Okay. Very quick announcement, just to see where we are. Okay. Right here. All right. So lectures will just be there. I may not remind you by e-class announcement all the time, so please always check for the YouTube link and also the notes, right? So everything is there. And notes template is also there. Your priority now should be to really complete Lab 0 Part 2. So this one here is definitely more demanding and more challenging to study because that one involves the use of primitive array. You have to make sure you get used to and also get yourself comfortable and convinced about the programming pattern that's going to recur for every programming test that's coming. Okay? So you'll be due next Tuesday, right? I'll try to remind you for Lab 0 Part 2. But if you can complete earlier, you should really try to complete earlier. There's no point to really wait until the last minute to submit. Your lab number 1 is going to be released on schedule next Tuesday. Okay, I'll let you know as soon as it's released. So starting from lab number 1, you will no longer have to watch the videos from me. So basically, you will be given JUnit test cases to start with, and then you have to develop everything from scratch. In some way, that's challenging, yes. On the other hand, it's very rewarding experience for you. That's the only way to get yourself a better programmer. Question somewhere? You answered the question. Oh, answer the question, right? Okay, good. Awesome. Okay, and yesterday, I did some live demo on helper methods. So if you were not there, if the time didn't work for you, that's okay. So the recording is there. Very easy to find. Just go to the lecture site. Okay, sorry, let me just go there very quickly. So if you go to the lecture site, and then it's basically the same page, same table. So you will see that in lab demo, right, from yesterday, right? So the notes, the example code, and also recording, everything's there, right? So it's really there for you to check out. And that one there definitely covers some essential stuff about helper methods, which I will recommend you to really try also in all the lab exercises you have. It's a very good practice for you to adopt. Okay. All right, and let's see. Next Wednesday. Next Wednesday, if you look at the calendar, okay, let's review that together again. Okay, always good to know where we are. So if we look at the calendar right here, so we are here today, right? So we are here September 11th. Next Wednesday is going to be optional, but it's going to be a mock-up test for your programming test 0. That's the only mock-up test I can provide during the semester. The first time, I want you to get some feel about what the atmosphere is like for a lab test. And your programming test 0, 1, 2, 3 will have basically the same formats, right? Except I'm going to make the mock-up test not like 80 minutes. I'll just make it 40 minutes. So you can just come and then attempt for that and for 40 minutes. And then I'm also going to make the question available to you also after the test. So you can try it just for the very first time. I think that'll be the most valuable experience for you to have. And also give you the solution as well afterwards. All right. And then the real test will start from September 24th on Wednesday. Right? So I'll also give you some guidance very soon, maybe over the weekend or early next week, just to let you know what you can expect from your programming test. The expectation for all the subsequent programming tests will be just the same. Maybe just the problem you're going to solve, and the coverage might be a little bit different, but the formats will always be the same. Given JUnit test cases, you got to figure out the Java code from scratch to pass the test cases. All right? All right, let's see. All right, guys, any questions? All right, so can you attend more than one mock-up test session? Yes, I think we should have enough space. If you really want to attend both, that's okay. And also for each lab session for the second half, about 40 minutes, either definitely the TA will be there, so they can answer your question as well. If you got any question about maybe lab 1 or maybe some other course material, I'll try to stay there briefly as well, so you can also talk to me if you want to. All right. All right, any questions before we do some quick recap? Okay, so recap from before. So the recap would be basically we spoke about the separation of concerns about model and also testing, right? So you will be given some JUnit test cases, and then you got to work out from the empty model package to develop all the Java classes and methods from scratch. That'll be the pattern. And try to avoid or at least try not to rely upon too much on the console tester, like assistant or other print line. You might still do it. It's okay. I'm not forcing you not to really do it, but we really encourage you not to do it because you really want to get used to testing your software using JUnits. And we talk about model, observe, model, execute process. So this is actually quite fundamental, just to know what's really the process of performing object orientation. Any programming language that will support object orientation is going to follow this kind of process. But for this course, we are just going to focus more on these two stages, the compile time of defining Java classes, making sure you have no syntax or type errors. And also we got a second stage where at the runtime, you're going to create objects, call methods, and also run test cases, and maybe you set a breakpoint debugger to find the errors, etc. Right? That's something you want to be very clear in your mind. What's the big picture of the flow? And correspondence between OO and OOP, mostly I will be referring to this vocabulary over here, but it's okay. Sometimes if you also refer to these, I think it'll be understandable. Like templates, classes, instances, objects, etc. Okay. And so these 2 points are very important. Let's just review them quickly. Entities of the same kind, meaning that objects of this instantiated from the same class. For example, Jim objects, Jonathan object, they're both person objects. Objects of the instantiated from the same class, they have the same set of attributes, meaning that Jim has the weight and height attributes. Jonathan also has the weight and height attributes. On the other hand, what would be the specific values for the attributes? It really depends on the objects. It might be the same, it might be different, right? 2 persons may be of equal weights, or maybe their weights are different, right? It's really just simulating the reality. So values of the attributes among entities of the same kind, they may be different, all right? So these 2 points are very, very important for you to understand. So the context object is always going to determine what's going to be the effects of calling the methods. That's also some point you want to keep in mind too. All right, so this is actually some discussion based on the question your fellow student from section B actually asked. So that's something you should also study for. So let's say if I got 2 methods, but in this case, constructors are like methods as well. But usually we don't really say constructor is a regular method. But let's say it this way, so they work the same way. So here we got constructor over here. They got exactly the same list of so-called parameters, which I will clarify also formally today about parameters versus argument. We'll do that today, a little bit later. So here you're saying the input for this constructor here takes only a single double. The input for this constructor here takes another input. You might be thinking, I'm naming this input here as W for weights. I'm naming this input here as H. So they're different, so I should be okay. The answer is no, you are not okay. I'll encourage you guys to really try out these 2 constructors in the person class in Eclipse and make sure you got the compilation error. The error is if you try to use these 2 constructors, let's say if I say Jim will be new person, I simply pass a double number. It's ambiguous. I don't know really whether this 72.6 is really for this or for that because both of them are expecting double. So ambiguity. So that's why it wouldn't even compile. So you cannot even run the code. How do we fix this? The principle of fixing this is you want to make sure the list of input types to be distinct among different methods of the same name. So what we did was we say over here, you can say, let's say for the first constructor here, we say double and double, 2 doubles. And the second one here, just 1 single double. Right? So now we can nicely actually distinguish between these 2. So now when I create Jim, I pass only a single double. So I would know I'm really passing just the heights, this version. On the other hand, when I create Jonathan, I'm calling another version of the constructor with 2 doubles. So I will know it's really these 2 doubles of the other constructor, right? So there's no ambiguity. So this will be one possible fix, right? So when you actually develop your side projects or for the lab, you always want to keep in mind, when you got methods of the same name, they must have distinct lists of input types. The names of the inputs don't really matter. Question? Yeah.
If I have another attribute like int age,
Mm-hmm.
and then I make another constructor for that. So int age, for example, and double height, would the compiler be able to differentiate between?
Okay, I see exactly what you're asking, but let me hand wave a little bit because that's something I'm going to cover also deeply next week. So what your fellow student was asking something like this. If I got integer, let's say h, right here, as another attributes, you can see the name here clashes with this name over here. Is it allowed? The short answer is it is allowed. All right? Maybe that's your question?
I was talking about age, if I have like the person's age as another attribute.
Okay, and then?
And then I make another constructor with that. So then it's also a single parameter, similar to the person double h, except this one's int instead of double.
Yeah, that's fine. So you basically just got, oh, I see what you mean. So person and the integer h. Okay, I see. So here you got double here versus integer. I think that should be fine. But why don't you double check and let me know? Okay, I appreciate that. Okay, but I believe they are distinct types. Double and integer, they're different.
Most of the time, even passing parameters, if you pass, for example, 3, you're not sure when the compiler...
Yeah, so that's why it's better to try. And then maybe confirm with me, and then maybe I can announce it again, just to clarify. Yeah. Mm-hmm. Yeah. So I think all these kind of details, sometimes it's very easy to remember, but sometimes it could be a little bit tricky. So always try. Okay, let me know. All right, good question. Okay, so just some checklists for the ingredients for OOP, especially for refactoring. That's something I did in the demo yesterday. So please check out the video from yesterday about helper methods. And the dot notation is really something that we're also going to talk about in many occasions for this course. Definitely, dot notation is a very special feature for OOP because you can navigate between classes or objects at runtime. That's something we'll see as well. And so these slides are for your study from slide number 9 to 47. All right. And we'll talk some of them, with some highlights. All right, so this, excuse me. So this example here is also very critical. So that one kind of summarizes some very common pattern, just about how the methods can be called on either the same or different context objects. First of all, whenever you're making a method call, the left-hand side for the dot is called context objects. That's some term you must know, all right? Context objects. And then if you compare, for example, 1 and 2, you can see we're calling the same method, but the context objects are different, right? And if you compare 1 and 5, over here, the methods being called are the same. And the context objects are also the same. But does it really mean calling this and calling that are going to give you the same kind of change? Not necessarily, because over here, the same context object has already modified its attributes by 2. All right, so that's kind of the discussion we had in that particular lecture. I will also ask you to really study that part as well, right? So this kind of changes really require some very thorough tracing of the program. And that's something we'll do a lot as well. Maybe not too much today, but definitely starting from Monday, we'll see more and more programs. In order for you to figure out the exact answer for the tracing, you have to trace it systematically, line by line. All right, so I think that's the last page, right? Let me recap very quickly, and then we'll continue. Okay, so for this one here, we're basically just saying about Java data types, right? We got primitive, which is integer I, okay? And just go directly there. Okay. So we talk about in Java, every variable should be declared with a type. If you have a variable without a type, it's simply not allowed. You wouldn't compile. So integer, and you'll see some list of the primitive types. You can see we got int, long, double, character, and Boolean, etc. Right? So these are all the primitive types. Okay? Anything that's not primitive is called reference type. Okay? That's very easy to actually distinguish, right? So you don't really memorize about what's really the reference type. You kind of have to somehow memorize or know what are the primitive types. For example, string. Is string primitive or reference? Reference. Yeah, good. So maybe just make sure you don't get confused. All right? And also, usually reference type, their name should be capitalized. It should not be all lower cases. That's also something you should notice too. All right, so let's now talk a little bit more about primitive type. So the way to really understand it is the type here is more like a set or collection concept. You can think about the int here tells you the set of integers, which can be negative, 0, or positive. And we're saying that I at the runtime can store any value that's drawn from this particular set. If you're trying to store any value into I that's not a member of this set, it's going to be compilation error. For example, you cannot store a character into integer. You also cannot store a string into integer, right? Because they simply don't belong to this particular set, right? The same principle also applies when we talk about reference type, but I'll get there in just one moment. So the way to really visualize a primitive type is like this, primitive variable. So one way to do it is you can simply draw a box over here. Oh, sorry. A box right here. And then if I say I here, and then if I simply got just the decoration without actually giving it an initial value, it's going to have some default value. And the default value for numbers will be 0, right? You know that pretty well. And what's the default value for Boolean? False, okay, that's pretty good, okay. So that one there, we wouldn't dive into very much detail into why it should be false. There's a logical reason behind that. But for now, it's okay. Just remember, the default value for Boolean variable is simply false. Or just to be safe, you can explicitly initialize the Boolean variable to be false, just to be sure, in case you forgot, right? All right, so that's about primitive type. And let's talk about reference type, which we'll encounter more often into for this course. So we got, okay, another example here. Let's say person P. Let's start with the type name right here. So you can see the person here, right? And as I said earlier, reference type by Java convention, it should be capitalized. The first character should be like a uppercase, but you may have compound words, in which case every component of the word should be capital as well, right? You will see many examples later. So person here, it is two possibilities for the name of a reference type. Okay, I'll write them down here. Number one, it could be a class declared within your projects. And this is going to be mostly the cases for this course. So any reference type you're going to use in your lab or in the programming test, most likely there will be a class you define on your own, okay, in the model package, most likely, okay. And second possibility, maybe once you graduate from this course, or maybe even go beyond 2101, once you do your side projects as a more advanced programmer, number two might be a little bit more, also very common. External library class imported. External library class imported. Okay, for example, you may have heard of array list. Right? If you haven't done this in first year, don't worry. Most likely, you are not allowed to use it in the programming test anyway. All right? So in this course, make it simple. We stick to primitive arrays. Everything should be built from scratch. Okay? But I just want to let you know, any reference type can either be a class from your project or a class from some imported library. Okay? Either way. If it is neither, then most likely you will get compilation error because the class doesn't exist. And let's go to understanding what does it really mean when P is declared to be a reference type. Before I write down the answer, anybody would like to give it a try? It'll be somehow very similar to the primitive type, but the value we are storing is not like a number, but it's something different.
Is it an address?
It's an address. Okay, that's good, on the right track. Address of what?
Of the location of the object in the memory?
I like it. You say address of some location in the memory. Now let me be more specific. What's so special about that memory location?
The index of the...
Not index, no, not too low level. Okay, I think your fellow student is pretty good so far. It should be an address for somewhere in the memory block, somewhere in the memory. So now I'm asking, what's so special about the memory block?
It's an index to the members of the class itself. For example, if you have int age, int.
Ah, good.
It's appointed to
Yeah.
the memory block that has the values of this.
Very good, yeah. So basically what your fellow student is saying, that memory block, since we're declaring P to be person, the memory block should contain person-specific attributes information, right? That's very good, okay? So collectively, you guys are pretty good, right? It's really right. So I'll write it down exactly. At runtime, the P can store the, first of all, address of some person objects. But we can elaborate this a little bit more. First of all, it's address, right? We are storing. Also, address of some person objects. It's not the address of some string objects. It's not the address maybe of some table objects, etc. Question.
What's the difference between an address and a number? Isn't an address technically?
Good question. Okay. I would say they are you can think about there are different categories, right? So how about this? Hold this question for now. It's okay. Okay. It's a good question. Let me answer that right away. First of all, they're different. They're different category of things. When you say a number, for example, 1 or 2, minus 1, minus 2, 0, 23.6, just general numbers. Can be int or double, right? Numbers. However, when you say address, strictly speaking, you cannot really get the actual hardware address from Java code. What you will really get, maybe I'll try to demo to you guys maybe on Monday. I can do that briefly, okay? What you will get is something called pseudo address. It is something that's more like an identifier for the object that's unique, but it's not exactly the hardware address you will see. So to really see the actual hardware address, you will need to use a language like a C or even assembly language to see that, all right? So address over here, you can think about, it might look a little bit like a number. So it could be like, for example, 0, 6, 1, 2, 3. So usually it will be in the, I forgot exactly how to spell that. It's actually not base 2, but maybe base 8. I'll look up exactly the word. So it's more like a base 8 or base 16 number. In some ways, it's a number, yes. However, it's a number that's for you to uniquely identify a certain part of the memory. But you wouldn't want to think about it just like an integer. You can do arithmetic.
I'm thinking now about the addresses in actual C or the addresses in Java. What would be which type of address you're talking about now?
So address, so here I'm just making up some number over here. So what you will see in Java specifically, you will see something like, for example, you might say person at maybe some unique number. That's how they actually present, Eclipse. So that's why I said it's not exactly like a hardware address. It's like a pseudo address. However, if you actually try to use the referencing operator, let's say in C, you will get something a little bit like that. It's like an actual number, right? Yeah. But the bottom line just know, that either pseudo address or the real address, they're just distinct identifier. Okay, good. You guys are good. You're really asking deep. I like it. So these are really meant to uniquely identify a memory location. In the context of Java, you cannot do any arithmetic. You cannot say address 1 plus address 2. Well, address 1 added with 2 memory blocks. You cannot do that. No address arithmetic. On the other hand, if you actually do like a numbers over here, of course, you can do 1 plus 2 and 1 plus 23.6. Arithmetic is actually allowed, right? It's different. Okay. So for those of you who might be taking a 2031, the C course right now, or 2032, either way, right? If you take that course, you will see that in C, you will be allowed to do some arithmetic on the pointer, like an address. It's kind of fun, but very low level. That's not something we allow in Java. Okay, Java is supposed to be higher level than C or assembly. All right, anyway, so let's go back here. So it's the address of some person objects. And let's elaborate a little bit more. When I say person objects, it's really a memory block that's reserved for storing person-specific information. It's really a memory block reserved. We can say dedicated, doesn't matter. Reserved for storing person-specific information. Okay, not for storing string, not for storing products, not for storing Apple shop, not really, just person, because you declare that to be the case, right? I'm gonna do some visualization, maybe as a last example today, you will see a little bit more clearly. Okay, good. Let's see, okay, just give you one more example here. Okay, I'll put it here. Okay, right here. If I declare, let's say person, and then P1, and then you might use a new keyword, I just omit the detail here, just see the declaration. And then maybe somewhere later in your program, you declare another string variable, and string is a reference type. That means S can store the address of some string objects, for example, 2030 in quote. So we now got P1 and S. Two variables. One can be a type error. For example, if we say P1 is assigned to S. If we say P1 is assigned S, what does that mean? S is supposed to store some address for string. P1 is supposed to store the address of some person. Now I'm trying to store some string address into a person block. That's not allowed, right? So it's a type error. This is a very important type error you should be aware of, okay? This is not good. Compilation error, because the P1 is supposed to only store person objects, address. Cannot store string address in a variable storing person address. Okay, I'll read it out just in case you're taking notes. Okay, the reason that this variable assignment is not going to be valid is going to have compilation error. You declare P1 to be storing person address only, but now you're trying to store the string address into it. That's not good. Right? So I say cannot store string address in a variable storing person address. All right, so that's why. So just in case, I kind of ask you to explain why a particular variable assignment may not be valid. That could be one possible explanation you can give to me to show understanding. Okay. All right, so that's about data types. Okay, so if we, any questions? Yeah.
Is there a way to cast an address, maybe to an integer to play with it, then cast it back to an object or something like that?
So your fellow student was asking about casting, right? So I think one possible casting is you can cast maybe from double into integer. Maybe that's what you did earlier in the first year. That's something we'll see some example, maybe a little bit later, maybe not today. No. There's another kind of casting you can do. In some way, yes, you're somehow really trying to change from one type to another. We'll delay that discussion until we talk about the equals method, because that's going to talk something more about inheritance. Okay, so I'll rather not touch it just yet.
I know when you do it with paraphrasing, I'm talking about if you want to do arithmetic, actual C style arithmetic with pointers.
I'm afraid you cannot do that. Yeah, there are many pointer specific operations in C or in assembly that you simply just cannot do in Java. Yeah, so Java is not really supposed to be a language that kind of manipulate directly on hardware. It's just a different purpose. Yeah. Mm-hmm. All right, but for typecasting, we'll definitely get to very deep about typecasting a little bit later. Okay. All right, so the slide here is done about reference type, and then the next slide is about default values. Okay, so we spoke about for numbers, for Boolean, etc. Right? For the reference type, there is a keyword in Java. I'm pretty sure I've seen that in the first year called null. Okay, because we say that each reference variable is going to store the address of certain type, of certain objects. Null simply means the address currently is undefined. All right, that's simply what it means. So you got to be very careful, because if you actually, okay, I'll get there. Okay, just before that, let me just Okay, oh, sorry, let me go back. I'll talk about this one in the iPad as well. Okay, let me just make a quick notes. I think just before I talk about the null. So there's just a one-line summary. A declare type of some variable, let's say x in general. So the x over here can be either the I here or the p here, depending on it's either primitive or reference type. Okay? Denotes the set of values that is allowed to be stored in X. Right? For example, in this case, I can only store integer values. P here can only store address of some person objects in the memory. Okay? So it really depends on what the declare type is. And let's now switch switch more focus into reference type. Right? Because we know if you only declared P right here without initializing it, maybe using the new keyword, P is going to store something called null, meaning that the address is undefined. If you try to look up the address into some memory, you will get something called null pointer exception. Right? That's something I want to also review. Right? Null pointer exception, let me give you the conclusion quickly. Is it ever possible for you to completely get away from null pointer exception? Most likely not, because null pointer exception is a very common phenomenon. As long as you get some even a tiny logical mistake when you try to make a method call, you can easily actually run into null pointer exception. Your safest bet is to really try to program in as disciplined as possible. Maybe always try to check if the context object you're calling the method is really null or not before you try to call the method, or at least have some assurance yourself. Right? So that's something we can also talk about, like how to program in a disciplined way. But let's talk about the null pointer exception, just to understand it a bit more. So null pointer exception. To start with, whenever you see anything called exception, right? It tells you that it's not a compile time error, right? So when you are writing your Java code in the Eclipse and save it, let's say everything's okay without any error. The compiler actually cannot tell you if you will ever run into null pointer exception at the runtime, right? It's just not possible, okay? So this is actually a runtime error. You only know about the null pointer exception maybe when you run some JUnit test cases at the runtime, or maybe you try to run some application using your code. You can only know at the runtime. So this one here is a runtime error. All right, so under what circumstances can the null pointer exception occur? All right. Let me just write it down in text, and then I'll try to write some code, okay? It will happen if the context objects of some method call is null, meaning that it's storing an address as undefined. Okay, I'll just write a remark as well. Undefined address. Okay, that's a very easy simple definition to define, to describe when the null pointer exception can occur. Null pointer exception basically only occur when you actually got some dot notation calling a method. Let's see exactly how it will look like. Okay, so we talk about method call. Let's make the scenario very simple, and then I will generalize it and give you some little exercise to try together. So let's say method call. It will look like the simplest form. You have some objects here. Let's assume the object has been, may or may not be initialized. Obj here, dot, some method m. And you may pass some values over here, right? That's a method call. Let's try to understand each part here. Let's start with this one here. Obj. This is what we call a context objects. which is supposed to store the address of some memory block, depending on what the declare type is, right? And what about the dot? And the dot, again, from the C language point of view, is more like a dereferencing operator in the sense that OBJ is supposed to store some memory address. The dot notation simply says, I want to go to that particular location in the memory and see what's there. All right? So this one here is going to look up the address that is stored in the context objects. Look up and go. And go there. And the way to understand about this method here is once you go to the memory block, you're going to apply whatever definition it is you say for n. Apply to that memory block. Apply the definition of the method to the targeted memory block. So think about if this is a memory, okay? Like a sequence of bytes. And then somehow the variable here, let's say obj, is supposed to store something right here, right? Maybe something, some address value. Look it up, and then you might just go to that particular address in the memory and then go to that block. And once you go to that block, you're going to apply the definition of n on this particular block. So this is the scenario where everything succeeds. How can it fail? It will fail if obj here stores null. In that case, there is simply no memory block there because there's null. The address is undefined. There's no memory block for you to apply n. In that case, it's going to be a runtime error called null pointer exception. Yeah?
Does actually Java store the methods again and again for every class, or does it do it in a one lookup table that all the classes will go to?
Yeah, exactly how they actually store the method definition there. We wouldn't worry too much for this course. That's a little bit, again, maybe more like a C course that we should worry about. But I would say we can just assume that there's behind the scene, not our responsibility, there is like a lookup table to really see if I want to call n, where is its definition? We can look it up. Yeah. Okay. Yeah, good question, but just not exactly relevant for this course. Good. So memory block right here. All right. So we're going to say if the memory block doesn't exist, does not exist, because the address is null. Context objects is null. In that case, we get null pointer exception. All right, so that's kind of the logical flow. Okay, let me recap, okay, and then we'll do a little exercise to conclude this topic. Whenever you have a method call, the context object is supposed to store some address. That's not null, supposed to. And a dot here is going to look up the address and go to some particular memory block that's being targeted. And then once we go to that memory block, we're going to look up the definition for the method and apply to that block. Maybe we just want to modify maybe the weights information for that particular block, right? So if the memory block here it simply doesn't exist because what's really stored in the OBJ is simply null. In that case, we're actually going to run into null pointer exception, right? So whenever you actually run into null pointer exception in your code, you want to just be aware somewhere in your code, you're trying to invoke a method that's on a context object that stores null. Question?
Is there any case that we have a memory block but we don't have anything in it?
A memory block with nothing in it. If you say like an absolute zero thing in it, I don't think so, unless the memory block is unused. But we don't really have a way to really find out all the unused memory block. We don't have that in Java. I'll get to you. So however, let's say this. I'll just say that verbally. Let's say you got weights and heights attributes in the person, right? Let's say you have a constructor there that does not take any inputs. It simply say person. And that one there is simply going to leave the weight and height attribute of default values 0 and 0. But you're still storing zeros in both cases. It's not like you're storing nothing. You're still storing the default values. So the short answer would be, for our context, you will never run, unless it's null, in which case you cannot find anything. But if you can ever go to a memory block, like objects, there will always be some values there, even though they might be default values.
Okay, so if we don't have anything in the block, it's just, it doesn't exist.
Yeah, it just doesn't exist. Yeah, think about null here simply cannot lead you to any memory block.
Okay.
Yeah, null simply just undefined.
All right, thank you.
Yeah. Question?
So when we're writing like code, should we expect that there can be a null pointer exception and like handle it, or do we just assume that it doesn't exist?
I would say, okay, it's a good question here. I would say null pointer exception is really hard to check. It's really hard, right? So I think I'll try to maybe give you guys more tips when we run to maybe specific examples. But in general, you just want to make sure every time you're writing a method call, you kind of want to ask yourself like a reflective question. When I'm calling obj.m, am I really sure at this point obj is guaranteed to be not null? Ask yourself this question. If you're somehow convinced that it should be not null, then just go ahead. If you're not really convinced, you may want to check to make sure if obj not equal to null, then you do that method call.
So do you check the case where it would be null and you try to write code around it to not be null?
Yeah, it may not be necessary for every method call, right? So let me just hand wave a little bit. So let's say for this one here, what you want to also avoid doing is really do it too much, right? You certainly don't want to say for every line of method call like this, I was surrounded by if obj not equal to null, I'm going to make the method call. Otherwise, I don't do anything. That would be too much, because that will simply, with that, pollute your code by too many if statement. So the proper balance would be, just ask yourself, when I'm writing this method call, am I guaranteed that obj at this point should be not null? If there might be certain scenario that obj may not be null, then I might need to check it. Okay? It's more like a vague principle, but maybe I'll try to once we get more examples, null pointer exception, we can say more. Okay? Yeah. Context objects. Yeah, good. Yeah, good question. Yeah, CO for our scenario will be context objects. Yeah, right here. Good. Yeah, guys, please keep asking questions. I don't mind being slowed down. Okay. Okay, good. Let's now consider one little exercise. Okay, I'll turn a new page. Okay. Let's now consider a method call where you got multiple dots. Okay, not a single dot. Single dot just for us to understand the basic principle. But let's see this like an exercise. Okay. The method call look like this. Let's say we got CO, the context objects, dot, and 1, and then dot, and 2, and then dot, and 3. Let's assume this line here compiles. Let's assume. All right, so compilation is okay. However, we're not exactly sure if at the runtime we're going to run into null pointer exception. That's something we only know when it actually happened, right? So the question would be, so guys, hello? Guys, hello? Please. Yeah, I understand that. Yeah, please, even whispering kind of distracting to me. It's unfair to your fellow students, right? So please, I appreciate that, okay? Okay, so there's a method call over here. You can see we got 1, 2, and 3. 3 dots. So based on what we just said, we know immediately how many times do we have to look up the memory? 3 times, right? Each dot is going to be 1 time, right? Exactly. Okay, so here's my question. Two questions, actually. How many possible causes for null pointer exception? Let's say this compiles, but at the runtime, we got null pointer exception. Okay, 3 here Any other answer? 3? Okay. 3 makes sense because I kind of gave you hints right away, right? Because we're going to look at that memory for 3 times. Any one of them can fail. If they fail, null pointer exception. All right? First of all, we're going to say 3. But we're going to dive deeper. 3 here, simply because we got number of memory lookups using the dot. Okay? So this will be dot number 1, dot number 2, and also dot number 3, right? 3 of them. Okay? And the follow-up question. What are the exact causes? What are the 3? Right? Okay, I'm pretty sure you know the answer. Anyone want to try?
Maybe the first one is CO is not. Like,
It's actually, yeah, maybe CO is null, right? That's very good. So the principle would be the way Java is going to execute this method call here is going to go from left to right, right? So you go, okay, very good. So the principle is execution at a runtime. Left to right. So the first one is going to be this one here. You can think about it's going to look up CO dot. Right? It's going to look up CO. So cause number 1, CO may be null. If it's identified this is null, it's going to fail right away. If CO is not null, that means we will be able to call CO.M1. And now CO.M1 becomes the context object of this dot over here. In which case, we have to look up again to call M2. Now, in this case, CO.M1 may be null. All right? So let's say this one here. So here, you can think about this will be a second cause. CO.M1 right here is the context object for this second dot. And it might be null. In which case, it's going to fail null pointer exception because you just cannot apply M2 to sound null, right? What about the third one? Let's help me complete it. What about the third one? Similar, right? Third one, yeah? Go ahead. What's the third one?
CO.M1.M2.
Yeah, exactly, right? Good, good. Awesome. And then I'll give you guys some practical tips as well, how you can actually do this in Eclipse, okay? So let's say this one here. This will be the third one. So number 3, CO.M1.M2. So CO.M1.M2, so this whole thing here is the context object for this third dot. That might be null, in which case you cannot apply M3. So, right? Maybe no. Okay? So these are the 1, 2, 3, right? It's you can think about the 1 and 2 and 3, right? I just put it here, right? That's the answer. Yeah, just before I take your questions, how do we do this kind of check in Eclipse? Let's say somehow you identify that you actually got a null pointer exception triggered by this line here, but you're not exactly sure where. What should you do? Breakpoint and debugger. So what you should do is you should really put a breakpoint and run the debugger. In your tutorial for lab 0, maybe part 1 already, or at least part 2. So there is something for looking up some expression. There's an expression panel there. That's what you should do. Basically, set a breakpoint in this line where you believe this null pointer exception. Pause over here, and then on this point, you want to check all the 3 possible causes and see which one is null. Is CO null? Is CO.M1 null? Is CO.M1.M2 null? You can check all 3 of them in the expression panel. That's really the value about using a debugger. Yes?
Can we say that we can get a null pointer exception from whatever happens inside M3? let's say you're printing out some list.
I know exactly, yeah, I know what you mean. So it's definitely possible. So what your fellow student said is also valid. Maybe for M1, M2, and 3 individually, they're complicated enough. Maybe in the halfway through of executing those methods, you might get null pointer exception, indeed. In which case, you may have to step into the method and find out. I agree, yes. But here, I'm just making it a little bit more conceptual, right? Just for you to see. Yeah, absolutely. Very good thinking. All right, guys, any question about this? Yeah, got a question.
Why we say there are only 3 points of maybe there's a point there and said I'm one.
Yes, I agree. So here, of course, I'm making some assumption over here. Maybe I should have said, I agree. Maybe I should have said, let's say M1, M2, and 3 itself does not have any null pointer exception. Maybe that's what I should say, right? Because I know that's exactly what your fellow student was saying. Maybe inside M1, we might have some null pointer exception, right? I agree. Yeah, but not, I'm making that assumption. Yeah.
If one of the methods were called without null pointer exception, doesn't that mean the context object already exists? So then the rest of these are gonna run, unless they do have null pointer exceptions, then it's already.
Yes. Yeah. So think about what's going to be the order of evaluation. The order of evaluation goes from left to right. First of all, evaluate CO. And then if CO is not null, then evaluate CO.M1. If CO.M1 is not going to cause you any null pointer exception, go ahead and evaluate CO.M1.M2 and etc. You go one by one at the runtime. At any point, at the earliest point where you fail by some null pointer exception, that's where you're going to see the null pointer exception. But for us to really debug the code to figure out exactly where, we just need a breakpoint and use the expression panel to figure out which one.
So assuming like there's no null pointer exception in them as well, inside the methods themselves, if the first one runs, isn't the M2 also going to call the context object like the same address which already exists, which means if M1 called it, that means it exists.
Yeah, let me make it clear. If there's no null pointer exception, let's say, right, just normal run, that means we're going to evaluate CO and evaluate CO.M1. That one presumably is going to give us some address back. So using the address, we can call M2. And that one there presumably is going to give us another address. And then we say that address.M3 and so on. Whatever the final outcome is the outcome for the entire thing. So we go from left to right.
So the address could change between the methods?
Yeah, depending on where you're talking about, right? Because CO itself is one object. CO.M1 is one object. CO.M1.M2 is just another one. Every time you have a dot notation here, that means the left-hand side is some objects. Okay, good question. All right. All right, guys, why don't we take a very short break by taking one more trial. Well, I shouldn't say one more. That's the first time you guys are taking trial attendance, right? Why don't we take a trial attendance today? I will do the real thing from next Tuesday, okay? All right, so to start with, I want to clarify some important terms. Parameters versus argument, right? So I think sometimes people like to use just arguments or just parameters, but you want to really distinguish between when to use which. So they do indicate some very important programming context you have to be aware of. So later on, when we talk about the equals method, and also a very important concept called call by value, you will have to know what really is parameter and what really is arguments. So let's now clarify this right away. They're quite easy to actually clarify, okay? So we got over here parameters. Right here. Whenever you talk about parameters, you're really referring to the definition of the methods. Okay, I'll give you examples right away. You can see here we are defining the class point. We basically got kind of constructor. We got two methods here. We got the accessor and mutator, right? We got these all three. So we got X here, we got Y here, we got other here, we got direction, and also we got units. So all these are part of the definition of the methods. So we call these the parameters, right? All these are parameters. On the other hand, when you talk about arguments, it's really when you try to use these methods in some other class. Or could be in the same class, but just to make the illustration more simpler. So it's when you try to use or call the methods. So for example, you can see that here we are calling the constructed point, which is right here. And here we are calling the get distance from, which is right here. And here we are calling the move method, which was defined right here, right? So okay, think about these are the usages of these methods, right? So whenever you want to use the methods, typically you will just pass some value or maybe some variable. So all these are called arguments when you actually try to call or use the methods. So here we say the 2.5, this one here, this one, this one, this one, this one, this one, and this one. So all these are called arguments. This one, this one, this one, this one. Okay, all these are called arguments. Right, very simple distinction. And you want to know when to refer to arguments and when to refer to parameters. So when I talk about these two terms, you also should know what I'm talking about, right? Just try to get used to it strictly. Okay. Okay. And the next topic will be about something called variable scope. Okay. It's also a very simple topic. So that's something you also want to play with the example a little bit yourself. I'll give you some guidance. I'll give you some example, but you should really know when to really refer to which variable. So there's certain scope rules you have to follow. Okay, let's see. So we start with attributes, I and j. Whenever you declare any variables outside any method, you can see method here, and I and j are just at the same level as the method. So these are called class level variables. So these are attributes. So they are the class level variables. Or sometimes you may have heard about the term fields. But I think that's more in the procedural language. So, but usually in Java, we say attributes. And similarly, we also got the name of the method. For example, M1 over here. And also we got M2, right? M1 and M2. So these are, we set at the scope of the whole class. You can think about it's going to cover, the scope is really right here, the whole class. That means you can refer to I, J, M1, M2 anywhere you like in the same class. Okay? We're talking about just within the same class. Right? The more restricted variables will be the parameter and also local variable. So you can see right here, P1 and also M. Okay, you can think about P1 and also M. So these are the method parameters and also local variables. So they are at the method level. And when I say method level, it must be the method specifically where they're declared, right? I'll give you some example in a moment, but you can think about P1 and M. Their scope is only within this particular method. You can only refer to P1 and M inside the green. You cannot, for example, refer to P1 and M right here, for example. You cannot do that, right? It's a different scope. And similarly, if you look at the parameter over here for the different method, and also the local variable here for a different method, right? What's the scope? It's only for that particular method, right? Right here. Okay, right here. Questions? Straightforward? Okay, yeah.
So we can use I and J in both M1 and M2.
Good question. Let's do some exercise together. That's something I want to cover. Yes, let's play with some different possibility. Okay. So let me just copy the same block of code. Okay, right here. And let's now see different possibility. For example, let's say here. I here, I can say I is simply J. That should be okay, because they are both class level. On the other hand, if I try, J is assigned, for example, let's say P1. this would not be good. Also, if you say J is assigned to P1 or N or P2, they're all going to cause you compilation errors. Okay? And then, let's say within this particular method, if you say M is assigned, let's say P1, would that be okay? Yup, indeed, because they both belong to the same scope right here. So this one will be fine. On the other hand, if later on you say N is assigned to, let's say P2, not good. Because N belongs to this scope, P2 belongs to this scope, completely different scope. It's not going to work. Right? So what I would encourage you guys to do is to create something like this and play with different combinations and convince yourself why one is going to compile, but the other one is not going to compile, right? I kind of give you the basic. Another one that's kind of interesting. Another one. Let's say in this scope over here, can I say P2 is assigned to N? I am assigning the parameter P2 to the local variable N. Does it compile? It does, because they belong to the same scope. All right? It does compile. Because P2 and N, they're both in this scope. However, I'm mentioning this as a look ahead. Later on, we're going to see. This one here, you can do it as long as you know what you're doing. Okay, so the stuff over here has to do with some discussion about call by value. That's something we'll cover when we talk about the equals method later. Compiles, but I gotta make sure what you're doing. All right. Okay, this is done. Okay, let's do some visualization. Okay. Go ahead.
Can you go back?
Of course.
I know P2 equals N. It's not the same as N equals P2, but I don't know why.
Okay. Briefly speaking, right here. If you say P2 equals N, number two, if you say N equals P2, right? Apparently for this one here, you're storing the value in N into P2. You're changing P2 basically. But here, you're storing what's in P2 into N. So you're changing N, right? So think about the left-hand side of the assignments is something we call the L value, but it's being changed. Right? On the other hand, the right-hand side over here is what we call the R value. And they're just being used or being referenced. Of course, they're very different. The order does matter. Okay, I'm glad you asked. You know, basic, but you guys should know. Okay? Yeah. All right, so let's now, 12 minutes. Let's see how much you can do. Okay. Let's now do a little bit more visualization, right? So I'm going to trace the code in a more efficient way with you, not using the memory block. Let's only do it once. But I think you got something similar for Lab 0 Part 2 as well. But you know, some repetition might be able to reinforce your understanding. Let's do it. Okay. So what we're doing here is we have basically person class. We got weights and heights, double. And also we got a constructor over here that does not try to initialize any of the attributes. In which case, both attributes are going to have default values, right? They're not initialized. So over here, all attributes left with default values. And this one here is going to assign weights and into weight into weight and height into height. I'll trace this one here a little bit more deeply, maybe next time on Tuesday with you. Okay? And notice something here. I deliberately choose the parameter name, new weights as opposed to weights, and also new heights as opposed to heights. Just make it a little bit easier for tracing right now. However, as you the more common you will see will be you will actually have to put just weights, the same name as this. Also, you put heights over here, the same name as this. However, if you do that, you got to watch out for something called variable shadowing. And that's something I will cover on Tuesday. I want to give you a little bit look ahead. Okay, but you can feel free to also look at the slides. Okay, so let's see how we can visualize. So here I'm giving you two example usages of the method here. So one is about using just console using print line, but you can take a look, right? But let's look at a JUnit test. That's something I want to look at. So what we're doing is we got new keywords. Whenever you have a new keyword, that means you want to create a new memory block with some distinct address. Okay, both of them should be for person objects, for person purpose only. Okay, let's trace them very quickly. So here we say new person over here. That means we're going to create a block, let's say right here. And that block has some address. Let's say I'll make it up. So it's 06123. And that block here is only going to be for person. And person has the weights and heights. So you can think about one is going to be weight, the other one is for heights. Right? And then we got 72 corresponding to the weights. 1.81 corresponding to the heights. So 72 and 1.81. I'll trace that a little bit more deeply next time. Okay? But for now, you just get an idea. So we have allocated one memory here. And now we're going to store the address of this memory into the gin. Right? So think about gin is going to be a box right here. Storing 06123. Okay? Similarly, we're going to have this new expression here. Okay? And we got this block over here. That one there guaranteed to have a different address. Let's say 06789. Also, that one there has the weight and height, right? Weight and height. And then 65 and 1.66. 65, 1.67. And then we store this address here into Jonathan, right? So right here. 06789. So this kind of visualization is completely valid. It kind of shows you about a very nice connection between object creation and the memory block. However, for the rest of this course, this is not the way to go. Nice drawing, too time consuming. We have a better way to draw more effectively for you to answer questions, which I'll show to you starting from Tuesday. Okay, but let's live with this just for today. And we have some assertion over here, okay? I'm going to elaborate about how to understand these assertions. Bear with me. But now question for you. Jin not equal to Jonathan. What does that mean? Go ahead.
Comparing the object addresses.
Compare addresses. So this address, they are not the same. That means this Boolean expression here is true. And we are asserting true. So that will pass. Okay? On the other hand, Jin equals Jonathan. This address, the same as this address, false. However, we are asserting false. Asserting false, something that's false, pass. Okay? Now something might cause a little bit confusion. I want to talk about it as well. Okay? But at least you know that this one here should be false. Okay, let me talk about it right away. Okay? So we talk about two things. We got JUnit assertions and also Boolean expressions. We got JUnits assertions. It's either pass or fail. You don't really say a JUnit assertion is going to return true or false. That's not the right way to say it. A JUnit assertion either pass or fail. No other possibility. Okay? So when you say, for example, when you say assert true, or you say assert false. So these two assertions may either pass or fail. There are other assertions as well, like assert equals, assert same, similar, either pass or fail, either not true or false. On the other hand, if you actually got a Boolean expression, it will be either true or false. And you don't really say a Boolean expression pass or fail. Again, it's the wrong way to say it. Okay? So, for example, when you say Jin equals Jonathan versus when you say, oh, sorry about my writing. Jin not equal to Jonathan, right? So these two Boolean expressions either will give you true or false. You don't say they're pass or fail. How do we combine these two things together, right? Let's now see, okay? Whenever you say assert true, and then over here, you're going to have some Boolean expression. Boolean expression, right? Now, this Boolean expression that's being asserted to be true may either be true or false, right? If it is true versus if it is false, we're going to have either pass or fail for the assert true, right? If this is true, we are asserting true, pass. If this is false, exactly opposite of what we are asserting, so that should be fail. So this one here should be pass, and this one should be fail. So true or false refer to what's really inside here. Pass or fail is about the result for the assertion itself, right? So they're different, okay? Symmetrically, we also got assert true, assert false. And we also got some Boolean expression here, similar, right? And this one here can, again, the Boolean expression can either be true or false. And what's going to be the result when it's true? Fail, because that's the opposite of what you're asserting, right? Exactly, okay? You guys got the idea. So this one here should really fail, and this one here should really pass. We good? Okay? Take this understanding here and go back to the previous page and also try to redo the example. All right? We got 4 minutes. I think I can do one more example. Okay? Can you guys please bear with me? I want to get one more page. Okay? Just give me 30 seconds. Okay? Just bear with me. I'll just get an example out. Okay, almost there. There we go. So I want to get that one. Okay, just one more example, and then we'll continue on Tuesday. Okay, one more. Sorry, copy is going to take some time. So this example here is just to show to you about using accessor versus a mutator. I think that's kind of easy example, but let's go over that. Okay, this one here. So we talk about accessor versus a mutator. Whenever you talk about accessors, it's really a method that returns something that's not void, right? Non-void. On the other hand, mutator, you can think about conceptually, it doesn't return anything. But syntactically, the return type is void. Simply means nothing returned from the method you can use. Okay? And let's see two simple examples here. Let's say in the person class, we got mutator and we got accessor. Right? So think about this one here is the mutator. Sorry, this one is the mutator. And this one here is the accessor. Okay? Returning something. And for all these 6, 1, 2, 3, 4, 5, 6, we're going to determine whether or not it's going to compile. Okay, compilation. All right, so let's see. First of all, let's talk about the set weights method, which is a mutator. I'm basically calling set weights right here, set weight right here, and also set weight right here. I'm calling set weight in kind of different context. How about the first one? I'm saying call gym.set weights and then print out its return value. Does it return anything? No, doesn't compile. Even though it's void, you cannot print void, by the way, right, in Java. Also, I'm trying to assign the return value and store that in W. You also cannot do that. You cannot store void in anywhere. So that's why these two simply do not compile. Okay? You cannot really put the mutator call in either to print it out or to assign that to somewhere. The only thing you can do is by using that alone, by calling the mutator. All right? That's the only thing that's allowed. Okay, accessor. Accessor is kind of the opposite. Accessor, like a get BMI, is supposed to return to you something, get BMI. So you can definitely try to print it out. You can also try to assign that to some variable to change its value. That's okay. So these two will compile, easy to understand. Now, the last one, let's talk about, okay? What about I say gym.BMI just by itself? I'm not printing it out. I'm also not assigning it to anywhere. Is it going to compile?
I think it is, but it doesn't really.
Ah, that's exactly right, okay? So I think you found it. Give me 30 seconds, 1 minute, guys, please. Okay, 1 minute. This one here is going to compile. However, it's not doing something useful. Think about this. You spend all the computing resources computing for the BMI, but you're not really using the value, even though it compiles. Useless, all right? So this one here, let me write it down, and then we're done, all right? So this one here simply tells you it compiles, but useless. All right, we'll continue from here on Tuesday. Please make sure you complete your Lab 0 Part 2 as soon as you can. See you next week. One more.